everybody and welcome. So in this video I'm going to explain how to build MATLAB application using Matlab App Designer. So through this application we're going to be able to set all our model parameters, and we're going to be able to run simulation directly from the application. So in this example, this is the dynamics representing a normal motorized pendulum, and so this is the full differential equation giving our dynamics. And so the same dynamics, so the pendulum could be represented through all this model. And I will take the output. We'll take the output, which are the theta and the velocity, so the angular velocity, and we'll add them to an attitude output to the workspace to use after if we need to plot this data or to analyze our simulations. So the basic method in MATLAB, or the standard method, is to launch the simulation, to set the model parameter, and to launch simulation through a direct Matlab script. And so this is an example of a Matlab script. So here we can set all the parameters to the workspace. We can also define the initial values, so theta 0 and theta dot 0. So these could be directly set in the integrator initial conditions. And then finally what we need to is to open our Simulink model, which is in the same directory where we have our initialization script, and then we can execute a simulation via the function sim of this particular model. So we can, as you can see, we can launch the simulation directly from Matlab script, and then we can get the result of our simulation. So now what we're going to do is that we're going to build our own MATLAB application, which will allow us to initialize all these parameters and to do exactly the same via this interface. So first, what we need to do, we need to go to the home panel. Then we're going to select a new application. And so this is a new application interface. So this is a blank application. So first, what I need to do is that I need to add numerical values, numerical edit field to allow the user to set the model parameters. So first we have the mass, which is measured in kilogram. Then we'll take then we'll take another field to set the length measured in meter. We'll take another field, and then here we'll set the friction coefficient, which is measured in Newton meter per radian per second. And then we can start setting what we need to do else is that we need to add a button, and then we'll call this button run simulation. So this button, when I click on this button, what I want to do is that I wish to take these value into account, to save or to define the variable in my workspace, then to define the input of my simulation, and to execute my simulation, which represent in fact this model and all the input that I'm going to get from my interface. So to do this, what I need to do is to add a callback function to this button. So when I click on add a callback function, so it will automatically generate a function related to the action of the user when he click on this button. Okay, so let's start first. So by initializing the gravity constant, so which is measured in meter per second square. Then what I need to do, I need to set my mass equal to the same value which the user will input right here. So as you can see, if I go in the public access properties in the MATLAB application, I can see that I have, or the application, when I have added the numeric field for the mass, it will automatically generate the structure which will contain the value of this field. So I'm going to take this one. First, I need to take my application, which is the object of my applications, which contain all these properties, and then I will add the mass edit field. Then I will take the value of this mass, and then which is measured in kilogram. So now we'll take the value from this field, and then we will stock it in this variable. I will need to do the same for the friction, so which is called in fact C Newton meter radian per second. So application rate per second value, then which is measured in Newton meter per radian per second. Then I will need also to define my length, which is equal to the length edit field value, which is measured in meter. Then what I need to do, I need also to take the theta 0. I will initialize it at 3 pi divided by 180, and then I will take the theta dot 0, which is equal to 0 radian per second, and this one is radian. Okay, so next what I need to do, I need first to define my Simulink model. So my Simulink model in this case, it's called in fact models. So I will take this model and I will put it right here. So this will represent my model. Then I will need to open the system of the MDL. Next, I need to set all the inputs, and from the inputs, which I mean the model parameter, all the variables. So I will need to prepare all these information before launching a simulation. So to do this, I will define a variable called input, which is equal to a Simulink input. So it's a Simulink simulation input for the specific model that I have set right here. So now I will also need to set the variables in this input set before launching the simulation. So the mass variable, which will be used here in my Simulink model, will take the same value of this local mass variable, and this local mass variable is the same as the variable that the user have input or have chosen in this specific field. Okay, so let's continue. Let's do the same for the length and for C. So, and or I'll need to do the same for the gravity also. So the gravity will be G, the length will be the same local variable L, and next we need to define the friction variable. Now what I need to do is that I will need to also set my theta 0 and my theta dot 0 to the same values as I define them here. So right now I have my interface, I have my callback of this particular function, and then what is needed to be done right now is that I will need to launch the simulation using this particular inputs. And then, so basically this operation, this line right here, when it's executed, so it will execute the simulation which contains this input. So the input, it's a simulation input for the model called models, which contain all these variables, and then the output of this simulation. So in this case, I only have the output to the workspace, which is the attitude, which contains the value of theta and d theta and theta dot. And then I will stock these variables into the array called output. This array could be used after the execution of the simulation in order to analyze or to plot data. So, and before running the simulation, before saving or running the simulation, we can right here put the default value, which will appears automatically when I open the application. So I will set them to 1, 1, and 0.5, for example, and then I can run the simulation. So I will need to save the application since it's the first time. Okay, let's choose another name, and then let's open this application. Okay, great. So now we have our simple interface containing the mass, the length, the friction coefficient, and then I can run the simulation using this button. And then, as you can see right here, I can get my output from here. So this is a small application. This is how to build small user interface, simple user interface to control our Simulink and to change perhaps all the input to our model and then to test directly from the application. In the next video, I will show you how to add another table in the application, and this table could be used to sweep, in fact, to take one of the parameter and to sweep the value of this parameter between a minimum and a maximum values with respect to a step between the values, between the minimum and the maximum, and then how to execute multiple simulation containing all these information, and how to be able to automatically plot all the data from all the values of this variation of this parameter on the data inspector of the Simulink.